Okay, so what we'll do now is I'll do a full example of graphing a rational function where we're going to combine all the important features that we went through in the last video. So I like to kind of break it into two steps, really. The first step is we're going to analyze the zeros on the top and bottom. We have a top and bottom because it's a rational function, so it's a fraction. And we're going to do that to find the vertical asymptotes and the holes. That is where the function's undefined, and that's going to be where? We'll pause and think. Yeah, it's a fraction where you're dividing by 0. So if the bottom is equal to 0, you're going to have something undefined, and so you're going to have either a vertical asymptote or a hole. And then where the top is 0, that's going to give you your x-intercepts, and then you plug in 0 for x to see what comes out as y, and that's going to be your y-intercept. So basically, we're just going to use the zeros of top and bottom to get all that information. And then the second thing to remember is the end behavior. What does the graph do as the input x goes to infinity and negative infinity? What's going to happen? Okay, so I'll do a full example for you guys. So we want to find a complete graph. A complete graph means it has all the things I listed above: the intercepts, any holes or vertical asymptotes, and the end behavior. So here we go. Find a complete graph of f of x equal x cubed minus x squared minus 10x minus 8. And it's a rational function, so I got to have something in the bottom. X squared minus 7x plus 12. All right. So first, I'll look at, I want to find the zeros, so that means I'm going to have to factor this, but this top is a cubic that's going to be a little bit difficult to factor. So what I recommend is just put that top polynomial in your Desmos and just find the zeros. And you're going to see the zeros are -2, -1, and 4. And once you get the zeros from the graph, then it's really, you can just create the factors, since we know from the previous lessons how the zeros and the factors are related. So we take the 3 zeros, we turn them into the factors. Okay, the top's factored. Now the bottom, you don't need to graph to get the zeros. It's just a quadratic, so you can factor that into x minus 4 and x minus 3. Okay, so once we got the polynomials on the top and bottom factored, we can easily find the zeros. So what do we want to find first? Well, let's look at where the function's undefined, so 0 is on the bottom. Well, we have a hole at x equal to 4, and I would ask you to pause and convince yourself of why that's true. Right, because we put 4, so we get 0. We put 4 in for x, and we have 4 minus 4. So we have 0 on the bottom, but there's also that x minus 4 on top, so it'll cancel out. And when you have the 0 on the bottom and the top, remember that's where you get the hole. And to find the point that is the hole, you just plug in 4 into the canceled version, and that's going to give you the output. So went ahead and did that, put in 4, we get 30 out, so we know there's a hole at 430. So I'll just highlight that with a rainbow box because that's one piece I'm going to make sure to put on the graph. All right. Now, what about other places that are undefined? Well, we also have 3 as a 0 on the bottom, right? But because it doesn't, since 3 is not a 0 on the top, then it's going to be a vertical asymptote at x equal to 3. All right, for the y-intercept, that's great. We just put in x is 0, see what comes out for y. That's where it's going to cross the y-axis. And we put in 0, and we just crunch that real quick, and we get, I'm not doing it very quick. 0 plus 2 is 0 plus 1, so it's -8 on the top and 12 on the bottom. So I guess it would be reduced down to -2/3. So our y-intercept is going to be the point 0 for the x and -2/3 for the y. All right, I'll go ahead. Oh, I forgot to highlight the vertical asymptote. That's important. All right, y-intercept. And then the last thing for using the zeros is the x-intercept. And where is a fraction going to be 0? when the top is 0, right? It can't be when the bottom is 0 because it's undefined. So we know that we're going to have x-intercepts at the zeros on the top, which if we look at the factored version, we can quickly see that it's going to be, I'll rewrite it down here, the factored version of that rational function, x plus 2 times x plus 1 times x minus 4 over x minus 4 times x minus 3. So on the top, we have zeros of -2, -1, and 4, but since 4 is a 0 on the bottom that's going to be undefined, then you just have the two x-intercepts of -2, 0 and -1, 0. Again, 4, you put in 4, you're not going to get 0 out because you're going to have 0 on the bottom because x minus 4 is on the bottom as well. All right, so we got two x-intercepts, -2, 0 and -1, 0. All right, now we're cooking with gravy. Or I guess we don't really cook with gravy much here in Thailand, right? So I don't know, cooking with sesame oil. All right, now we're going to analyze the end behavior. And again, I want to introduce this calculus notation we're going to see a lot when we get into the second quarter. The limit as x goes to 0. Again, that just means x is going to approach 0. What happens to this, which I'm going to write here? X cubed minus x squared minus 10x minus 8 over x squared minus 7x plus 12. I just rewrote the function down here so you guys can see it. Well, what's going to happen? Well, you can basically, on the top, the biggest thing that's going to dominate is the x cubed, and on the bottom, it's going to be the x squared. Everything else doesn't really matter, and that's going to reduce down to x, and as x goes to infinity, then that's going to go to infinity. So we know it's going to shoot, the graph's going to shoot off to infinity. Great. But can we get a little more precise than that with our end behavior and guidelines? Well, the answer is yes. You'll start seeing this when you do a lot of these problems. If the degree of the top is 1 more than the bottom, you're going to have a slant asymptote. Okay, if the degree is the same, it's a horizontal asymptote. And the way you find the slant asymptote here is you're going to just do the division, either synthetic if you're good with that, or if you're bad with synthetic like me, I have to do the long division like I'm doing right here. So we're just going to actually divide this polynomial out. So I have x plus 6, and I got to figure out the remainder. Although the remainder doesn't really matter. I'll show you that in a bit here, why that's the case. But okay, so I subtract and I get 20x minus 80, and x squared can't go into that, so I have a remainder. So the remainder is going to be 20x minus 80 over x squared minus 7x plus 12. Okay, so this is the same function, right? It's just written a different way because we did the division. So we're still looking at the limit as x goes to infinity of this function we just circled in red, but now we're going to analyze it in this form. It's going to be real easy to see the end behavior in the slant asymptote. So I said the remainder doesn't really matter because the bottom degree is higher than the top. So since that squared is higher than the degree 1, the bottom, as x goes to infinity, the bottom is going to be way bigger than the top. So if you divide, some number by 1 billion, you get close to 0. So that remainder is going to go to 0, and you end up with x plus 6. And that's going to be the slant asymptote. And we're pretty stoked about finding that. Okay, so now we're going to graph. I'm going to get my ruler out for you guys, try and make this nice and neat. So I'm drawing an axis here. Okay, make it a little bit bigger because I know I have that hole at 430. So I got to make a pretty big axis. All right, so now I just got to put all this information on the graph, right? So here we go. So we have the hole at 430. So it doesn't matter what order you put this information in, by the way. So whatever you want to do in terms of putting it on the graph. Okay, I'm too lazy to count out 30, so there, 30 is up there. Okay, so we have a hole at 430. So I'll draw that in. Okay, there. So there's the hole at the point 430. All right, the next thing I'll put in is this vertical asymptote at x equal to 3. Remember, vertical asymptote is going to be just a dashed line, dashed vertical line, just saying, hey, the function, we don't know what happens here at 3. It's undefined. So draw that in. All right, what else do we know? We've got y-intercept at 0, negative 2/3. So, and the x-intercepts at negative 2, 0, and negative 1, 0. So let's draw those in. So the y-intercept here at 0, negative 2/3. Okay, and I'm just labeling it just for clarity. By the way, when you're doing like a problem like this on the test, if you label the important stuff that I ask to include in the graph, that just really helps me grade it easier because I can just quickly see that you got it. All right, and then I put the x-intercepts negative 2, 0, and negative 1, 0. All right, so we have that. Now we can go ahead and put in the slant asymptote. So we got a graph x plus 6. So it's a line, just choose 2 points. When x is negative 6, out comes 0. So we have the point negative 6, 0. And if I put in 0, I get 6 out. So that's 0.06. So just get 2 easy points for the line, connect them, and there's our slant asymptote. All right, so we're almost done. We got all the asymptotes, we got all the holes, the intercepts, all that good stuff. But we still have a question of, I'm labeling the slant asymptote there just for clarity. Y equal to x plus 6 is our slant asymptote, that line. Now, the thing is, we know if it's going to follow the asymptotes as the guidelines, it's either going to look like that top that I just sketched out or that bottom. And how are we going to choose between those two? Well, we have to look at around the vertical asymptote, does it go to positive infinity or negative infinity? So I will choose something like 3.01, for example. And I don't really care the exact number. I only care about the sign, positive or negative. Because if it's positive, I'm going to choose the top piece of the graph I just dashed in there as a placeholder. It's temporary because I don't know which piece it is. And if I get a negative number out, then I'm going to fill in the bottom one that is going to go to negative infinity. So we just got to quickly evaluate this. So if I put in 3.01, then I'm going to get a, we just need to know the overall sign. And I recommend you use the factored version. It's the easiest in terms of figuring out what's positive and negative. So we have positive times a negative all over, 3.01 minus 4, so it's a negative times a positive. So overall, we are positive, and that means I can confidently fill in the upper part of that because it's going to go to infinity, positive infinity, as it approaches x equal to 3 from the right side. All right, now I got to look at it from the left side. 2.99 is good. It's close to 3 from the left. And all I care about is the sign. So it's positive, positive, negative, but then it's over negative, negative. So overall, we're going to be negative if we multiply and divide all those positive and negative signs together. And graph is going to look like this. And we're done.